Hello Math 8 students, this is Utah Middle School Math Project 1.1f, creating and solving linear equations to model real-world problems. This is part 1, there is going to be a part 2 later, and this is a shortened version of this lesson. So to get started, I want you to understand that what we're doing throughout this entire lesson, we're solving equations, yes, but the equations are not written for us. We have to write the equations, and we're going to get the information from a story. What I want you to notice, there's usually a section for each of these problems for a story. There's also a section where we have a bunch of information. This information is going to be where we write the small expressions that represent individual pieces of the story. So these are expressions for the story. We're going to take all of those expressions and then turn them into an equation once we get a little bit more information. Here's the story. Chloe and her friends are going on a picnic. A sandwich is 6 times the cost of a cookie. Do we know the cost of either one of those yet? No, but I know that a sandwich is going to cost more than a cookie. How much more? 6 times more. A bag of chips is 1.5 times the cost of a cookie. And a soda is twice the cost of a cookie. When I look over here, I can see cost of a sandwich is blank. Cost of a bag of chips, blank. Cost of a cookie, X. I don't know what it is, and that's why I'm using the variable X. Cost of a soda is blank. So I don't know anything, but I do know that the cost of a cookie is X. So this time as I read the story, I'm going to see if I can start representing this abstractly or algebraically. Chloe and her friends are going on a picnic. A sandwich is 6 times the cost of a cookie. How am I going to represent a sandwich being 6 times the cost of a cookie? Brigham? We'll multiply it by 6. What am I multiplying by 6? No. The sandwich is 6 times the cost of a cookie. So what am I going to be multiplying by 6? Lachlan? X, because the cost of a cookie is X, and I need 6 times that. So that's going to be 6 times X, X times 6. I'm going to write it better though. We mostly will write X times 6 as 6X, right? Okay, let's keep going. A bag of chips is 1.5 times the cost of a cookie. So how am I going to represent that? 1.5 times the cost of a cookie. Remember, the cost of a cookie is X. Angela. We're representing bag of chips. Was your hand up and you didn't mean for it to be up? Do you need more time? One and a half is multiplied by X. So how am I going to write that? 1.5 or 1.5, which is multiplied by X. I'm lazy, right? So I don't put that times X. I just know that it's there. And last, a soda is twice the cost of a cookie. So how am I going to represent that? Ike. 2X. Great job. That was pretty easy, right? As long as we take these little baby steps and we take the story and we represent that story over here as little pieces, then the next part becomes easy. We've already done part A. We have already written expressions to represent the cost of each item. And now let's read part B because the story isn't done. Chloe and her friends buy 2 sandwiches, 3 bags of chips, 4 cookies, and 2 sodas. This is how you know it is not current as of 2023, because 2 sandwiches, 3 bags of chips, 4 cookies, and 2 sodas only cost $12.25. I don't think you can find that for today's prices, right? I think this was written maybe 15 years ago, so it's kind of showing its age. But how can I turn all of that information into an equation? We're still going to take some baby steps. How many sandwiches did they buy? 2 sandwiches. So how many of these 6X's am I going to have? 2 of them. You can write it like that. You can come over here off to the side and maybe you want to say 2 of these. You decide. But I know that it's not just 6X, it's 2 of the 6X's. How many bags of chips did they buy? 3 bags of chips. So what am I going to do with this 1.5x? How many of those am I going to have? 3 of them. How many cookies did they buy? 4. So it's not just going to be X, it's going to be 4 of the X's. And sodas, looks like they bought 2. So 2X, but I have 2 of those 2X's. How am I going to represent all of that then? They didn't just buy 2 sandwiches. It was 2 groups of the 6X, because that's a sandwich. And they also bought 3 of the 1.5X's. That represents the cookies. But how am I going to connect these? I'm not even done, but how am I going to connect these? I'm going to multiply, add, subtract, divide. What am I going to do here, Ivan? Yeah, because it's and, right? Sandwiches and chips and cookies. Each time I say and, that's an additional thing that I'm going to be paying for. Now, how many of those cookies did we have? 4 of the cookies. And how many sodas? 2 of the 2X's. So I'm just going to label all of this right now. This was the sandwiches. This was the chips. This was the cookies. And this is the sodas. When I buy all of these sandwiches and chips and cookies and sodas, how much money have we spent? Yeah, so how am I going to show that? How am I going to show that all of that together is $12.25? Ivan? Yeah, an equal sign. And what does it equal to? It equals the $12.25. So we were able to take all of that information that was in the story. We were able to write it as an equation. Now that it's written as an equation, now we can solve it. We're still going to have to take some baby steps because I've got X in all of these different places. Oops, I forgot something. 3 times 1.5 X is what that should say there. Hopefully you guys caught that and had it correct on your own. I have all of these X's that I need to combine. So I need to figure out how many X's I even have. So before I do anything, I'm going to start simplifying. I have 2 groups of 6X. So how many total X's do I have here in sandwiches? 12X. I have 3 groups of 1.5X for the chips. So how many do I have? And you can use your calculators here. 3 groups of 1.5. 3 groups of 1.5. Some of you can do it mentally. What'd you get, Kaylee? Yeah, 4.5X. I have 4X, the cookies. I don't need to do anything special with that. I just have those 4X. And 2 groups of 2X in the sodas. 2 groups of 2X. So what is that going to be? 4X, yeah. And all of those X's together are still going to be $12.25. And I still don't know how many X's, but now it's just a simple matter of adding. Calculators could be helpful here. You should be doing that for sure if you can't do it in your brain. 12X plus 4.5X plus 4X plus 4X. How many X's do I have all together? Good. Happy to see a couple hands. We'll give a little bit more time as you're typing into your calculator or getting that brain to work. Brigham. 24.5X, 24.5 X's, and all of that is equal to 12.25. I'm almost done solving now. All I had to do was combine all of those X tiles together. I have 24.5. That means 24.5 is multiplied by X, and I'm going to undo multiplying by 24.5 by dividing by 24.5. And balance it, do the same thing to the other side. This divides out, and I'm left with X, which is equal to, you have calculators again, 12.25 divided by 24.5. Jaden, what did you get? 0.5. So what does that mean? We know that X is equal to 0.5, but now that we have solved this abstractly, now we need to make sense of it quantitatively. What does that X equals 0.5 mean for the story? Go ahead and talk at your tables. What does that X equals 0.5, what does that mean for the story? What does x equals 0.5 actually mean? Federico. And what is the cost of a cookie? You're right, because the cost of a cookie is x, and we just found what x is. So this is the cost of the cookie. But what does that mean? What does 0.5 mean for the cost of a cookie? How much are you going to have to put on the register for a cookie? Lachlan? Yeah, 0.5. What are our units of measure? Dollars. So what's 0.5 of a dollar? That's half a dollar. That's 50 cents. So a cookie, it was X, but I know that that actually represents half of a dollar, 50 cents. All right, then what's the cost of a soda? Soda is 2 times that amount. So what is a soda going to cost? You should need your calculators for this one. 50 cents. What if I have 2 50-cent pieces? What do I have? 2 times 50 cents. There it is. Braylon, $1. This next one might be more challenging. You might need your calculator for this. What's 1.5 times x so I can figure out the cost of a bag of chips? 1.5 times x, or 1.5 times 50 cents. Brigham? 75 cents. 0.75 or 75 cents. And lastly, the cost of a sandwich is 6x. 6 times 50 cents. Lachlan? $3. Let's review the steps that we took. We had a story. We used parts of that story to write expressions for each individual piece. We were able to put all of those pieces together with the rest of the story in order to form an equation. Once we have an equation, it's just like what we did previously. We solve the equation, but then once we solve the equation, now we have to interpret what that means in relation to the story. For right now, we're going to skip number 2 until we have a little bit more practice. I'm also going to skip number 3. Let's move on to number 4. We'll go back and we'll do those in just a second, but let's skip ahead to number 4 now. I did want them to be in that order, but in order for them to print on one page, I had to rearrange it, so that's why we're kind of skipping ahead. This time, the story is about Farmer Ted and him weighing his animals. So Farmer Ted is weighing his animals, and he knows that a pig weighs approximately 1/4 as much as a cow. He also knows that a Clydesdale horse weighs about twice what a cow weighs. A sheep weighs approximately 100 pounds less than a pig. It's a lot of information, a lot of numbers going around there, but now let's take a look. This is where we're going to have all of our little expressions. And it does tell us what variable we should use. Do we know the weight of a cow? No, but we know that it's going to be represented with the letter C, C for cow. So with that in mind, as we read through the story again, let's read through the story and see, what am I going to write for horse? What is the expression going to be? What am I going to write for sheep? And what am I going to write for pig? We're going to pause the recording as students work on that at their tables. Pause the recording now. Farmer Ted is weighing his animals, and he knows a pig weighs approximately 1/4 as much as a cow. How am I going to represent that? I can see the weight of a cow is C. How am I going to represent a pig being 1/4 of a cow? Ellie. 1/4 C. It's not just 1/4. It's 1/4 of the cow. 1/4 of the C. Brayden, does that make sense? Okay. A horse. A Clydesdale horse. Not just any horse, but specifically a Clydesdale horse. A Clydesdale horse weighs about twice what a cow weighs. What am I going to use to represent that, McKaylee? 2C. 2 times as much as a cow. This is where we struggled, so let's really put our heads together here. A sheep weighs approximately 100 pounds less than a pig. Now, let's just pause for a second. Let's pretend I know a pig weighs 300 pounds. Not 3,000, sorry. A pig weighs 300 pounds. Let's just pretend that. If a pig weighs 300 pounds, could you figure out what a sheep weighs? Because a sheep weighs approximately 100 pounds less than a pig. So if a pig is 300, then a sheep is going to be 200. Use that to see if you can figure out the weight of a sheep. Ellie, what did you write? Minus 100. That's a good start. But does that mean, think about what this means as it is. The weight of a sheep is negative 100. Do sheep have negative weight? No, so it's 100 less than what? Less than a pig. What am I using to represent a pig? 1/4 C. Here's the pig. How am I going to figure out, knowing that a pig is 300, that a sheep is going to be 200? I subtract 100. But what am I starting with? The pig. Yep, I'm starting with the pig. So the sheep is subtracting 100, but we're subtracting 100 from the weight of a pig, which is 1/4 C. How are we doing on that so far? Everyone understand? Okay. The sheep was a struggle, but that's why we really got to try and make sense of that. And that's why I broke it down using real numbers, actual numbers that I could make sense of. Okay, on the lines above to the left, write the expressions, done. I'm actually going to skip part B because it says, what if he had one of each? But he doesn't have one of each. Part C tells us that he has more. How many cows does he have? 3. So, how many of these C's am I going to have? 3 of them. How many Clydesdale horses does he have? 2 Clydesdale horses. So it's not just 2C, he has 2 of those 2C. How many sheep does he have? 4. So how many of these 1/4 C minus 100s? He has 4 of those. And he has 1 pig. So how many of these? Just 1. All of those animals, 3 cows, 2 Clydesdale horses, 4 sheep, 1 pig, they're all on a giant scale. One of those kind that you just put your truck on and it will weigh your truck. He has all of those animals loaded onto one of those big giant scales, and the scale reads 7,850 pounds. Let's use that to figure out how much each animal weighs. Now, I'm not going to have a ton of space to do all of the work here, so I'm actually going to write the equation up here where I do have some space. How many cows does he have? 3. And each cow is C. So I'm going to write 3C to represent those 3 cows. He has 2 Clydesdale horses, so I'm going to write 2. 2 of the 2C's. Now again, how am I going to connect these? Here's all of the cows. Here's all of the horses. What am I going to do between those? Add them. Cows and horses and how many sheeps? 4. Yes, that's 1 sheep, but how many of those do I have? 4 of the 1/4 C minus 100. And 1 pig. So just 1 of the 1/4 C's. What happens when I put all of those animals on the scale? What do I get? A lot of weight on the scale. 7,850 pounds. There's my equation. Now we just need to solve the equation. Go ahead and take those solving steps with your tables. Do the best that you can. We'll come back together in 60 seconds. So just take a 60-second head start and see how far you can get. We're going to pause the recording as you give it a try. Ready, set, go. Part of our simplifying part of our solving we have to simplify first. So the first thing I'm going to do is recognize that if I have 2 groups of 2C, that's going to be 4C. I don't want to forget about my 3 cows. They're still part of the problem. What is 4 groups of 1/4 of a C? What's 4 times 1/4? 1. That's 1C. Plus, I also have 4 groups of subtracting 100. That's going to be? Brayden, how's it coming? Okay. Plus, I also have this extra 1/4 of a C. And all of that is equal to 7,850. And now I need to combine all of my like terms. And I can see I have 3 C's and 4 C's and 1 C and a fourth of C. What do I have all together? Yep, 3, 4, 5, 6, 7, 8, and a fourth. I'm now going to convert this, instead of writing 8 and 1/4 C, because my calculator doesn't understand a mixed number, I'm going to change 1/4 to being 8 and a fourth written as a decimal. 8 1/4, 8.25. 8.25 C, but don't forget we also have minus 400. No different than the equations that we had before, right? Just got to simplify first, and all of that is equal to 7,850. You can take these solving steps. I'm going to undo subtracting 400 by adding 400. $8.25C is equal to 7,850 plus 400, 8,250. C is multiplied by 8.25, so now I'm going to divide by 8.25 and balance it. Same thing on the other side. Definitely out of space, so I'm just going to have to come up here. C is equal to 8,250 divided by 8.25. Yeah, I'm waiting because I'm waiting to see if you guys are actually going to do the work. Thank you. I can take this one. Yeah, C is equal to 1,000. But again, what does this mean? C is equal to 1,000. We solve the equation. What does that actually mean? Angela, who just barely came back in and is still going to give it a try. Go ahead, Angela. Yeah, that's how much the cows weigh. The weight of a cow is C, and C is equal to 1,000. So, what is the weight of a cow? 1,000. 1,000 what? Pounds is our unit of measure. 1,000 lbs, pounds. What about those Clydesdale horses? A Clydesdale horse is 2C. So that's going to be Lachlan, 2,000. So the weight of that Clydesdale horse is 2,000 pounds. I'm going to skip sheep for a second. Let's go to pig. A pig is 1/4 of a C. So what's 1/4 of 1,000? Ivan. 250. 1/4 times 1,000 is 250. And now it all goes back to where we started. The weight of a sheep is 100 pounds less than that. So the weight of a sheep is 150. 250 minus 100 is 150 pounds. Okay. Let's go back now. We're going to go back to problem number 2. Problem number 2 is backwards. This time, the story is incomplete. You have to finish writing the story, but all of the information that you need is right here in our expressions. So as we're reading the story, we're going to come back and look at the expressions to see if we can find some information. There's a little bit of notation that you need to understand here. The first is, it says in something. What shape is that though? A triangle. So what I'm saying is in triangle, ABC. All that means is somewhere there exists a triangle, and that triangle is labeled A, B, C. That's all that means. And we're talking about the measures of each of the angles. I could take a protractor and I could measure each of these angles. And that's what we're talking about here. But mathematicians are lazy. That's why we have a symbol for the word triangle. We also have a symbol for the word measure. We just use an M. And we also have a symbol for angle. Do you see that symbol that I just drew? It looks kind of like an angle in the triangle. So that is angle. Once we understand some of those pieces, then we can understand and read this a little bit better. So the measure of angle A is x. The measure of angle B is 3x. The measure of angle C is x minus 20. With that in mind, let's read and see if we can fill in the blanks. It says, in triangle ABC, the measure of angle B is 3 times larger than ... What are you going to write here, Lachlan? Angle A, because when I look at angle B, it says 3x. That's 3 of the x's, which match with angle A. So, measure of angle B is 3 times larger than angle A. The measure of angle C is 20 degrees less than ... Let's look at C. C shows x minus 20. That means 20 degrees less than what? Angle A again, yeah. If it were angle B, it would be 3x, but it just says x minus 20. So this is, measure of angle C is 20 degrees less than angle A. Sum. The sum is just a fancy word that means when I add. When I add up all of the angles in a triangle, it's blank again. What happens when I add up x, which represented angle A, and 3x, which represented angle B, and x minus 20, which represents angle C? What happens when I add up all of those things? I get 180. So the sum of all of the angles in a triangle is 180 degrees. We're going to learn more about that in our next unit, but for now we can just read the equation that's already built in order to understand. What is the measure of each of the angles in the triangle? Well, the good news is this equation was already built for us. Now we just need to solve it. X plus 3x plus x minus 20 is equal to 180. Let's solve it. I have an x and 3 more x's and another x. How many x's do I have altogether? Nope. It's in 3 different places, but how many total? 3, 4, and 5 x's. Don't forget our minus 20 that we still have. And that's equal to 180. It's time to solve. You guys can take those solving steps. We'll pause the recording as students solve this and then find the measure of each angle. Pausing the recording now. Okay, students have solved it. Now let's solve it on the video. I undo subtracting 20 by adding 20. Balance it, same thing to the other side. Now I have 5x, which is equal to 180, plus 20 is equal to 200. I am now going to divide each side by 5. And now I have x, which is equal to 200 divided by 5. Jaden, 40. Okay, x is 40, but now let's do something with that. If x is 40, what does that actually mean for the story? Angela. Yep, angle A is 40 degrees. So measure of angle A is 40 degrees. What's the measure of angle B then? 120, because it's 3 times 40, and 3 times 40 is equal to 120 degrees. And angle C is 20 degrees less than that, so 40 minus 20 is equal to 20 degrees. Let's just take just a second and double check to make sure I did this correct. What is 40 plus 120? 160 plus another 20? Oh, that works out perfectly since they do really add up to be 180 degrees. Okay, here is our final problem. In order to be successful with this problem, we need to understand average. And if it's anything like my last class, you guys don't know what an average is because you were COVID babies in your 4th grade year when you would have gone over average. So we're going to pause the recording. Anybody who knows anything about an average, how to find an average, I want you to share that with your tables now. We're going to pause the recording as I discuss. Ready, set, go. How do I find an average? Ike. Yes. First, you add all the numbers. Then, you divide by how many numbers you just added together. I feel somewhat relieved that at least when we say it, you guys are going, oh yeah, I did know that. Let's practice it first before we do number 3 together. So let's say I gave a quiz and one student, I only have 5 students in my class, and one student earned a 2. 2 out of 10. They did pretty bad. Another student got a 7 out of 10. Another student got an 8 out of 10. Another student got a 9 out of 10. And another student got a 9 out of 10. So let's find the average. What was the average score? What do we have to do first? Add all the numbers. So that's going to be 2 plus 7 plus 8 plus 9 plus 9. Once you have all of those numbers added together, I don't even care if you type it into your calculator right now because we're not done. Thank you for your attention. After I add all of them together, what should I do? Divide by how many numbers I just added. How many numbers did I just add together? 5. So I need to divide all of that by 5. Okay, now go ahead and add it together. 2 plus 7 plus 8 plus 9 plus 9. What is 2 plus 7 plus 8 plus 9 plus 9? Lachlan. 7? 2 plus 7 plus 8 plus 9 plus 9 is 7? 35. Thank you. But what do I do? Does that mean that the average student scored 35? No. What do I have to do after I add up all the numbers? Divide by how many numbers I just added, which in this problem is 5. And 35 divided by 5 is equal to 7. Now we know how to find an average, but let's read question number 3, because question number 3, I am not asking for the average. I'm giving you the average. I'm asking something else. So let's read it carefully so we understand what we're asking. Selena got a 54% on her first quiz, a 92% on her second quiz, and a 75% on her third quiz. Write and solve an equation to show what Selena must score on her fourth quiz so that she has an average of 80% in the class. Let's write some expressions. How much did she score on quiz number 1? 54%. I'm just going to put 54 and understand we're dealing with percents. What did Selena score on quiz number 2? 92% on her second quiz. What did Selena score on her third quiz? Yep, 75% on her third quiz. What did Selena score on her fourth quiz? Yep, on her fourth quiz. If you read the problem, it says, write and solve an equation to show what Selena must score on her fourth quiz so that she has an average of 80% in the class. So what did she score on her fourth quiz? Do we know? So what am I going to use? A variable, x. What is the average? The average is 80%. So let's think about what this means. How do I find an average? Add up all the numbers and then divide by how many numbers I just added together. So what are the numbers that I need to add together here? 54 and 92 and 75 and x. That's how the average works. We have to add up a number that we don't even know. When I've added up all these numbers, I need to divide, and what am I going to divide by? How many numbers did I just add together? 4. When I add and then divide, what do I need the average to be? 80%. This is like when you guys say, if I do really good, am I going to be able to get a B? I don't know. This is what we'd have to do to find out. So let's see if Selena is going to be able to score an 80 or a B minus. We need to simplify before we solve. I add all of these up together, and I can't add the x, but you know what I can add? I can add that part. What's 54? Plus 92? Plus 75? What did you get, McKaylee? I'm sorry, you're going to have to be a lot louder than that. I can't hear you. 221? That takes care of this part, but I still have to add that fourth score, whatever it might be. And when I add all of that up together, I still have to divide it by 4 because there were still 4 scores all in here. All of that is equal to 80. You can solve this equation. X, we're adding 221 to x, and then we divide by 4. How do I undo dividing by 4? We multiply by 4. Anything I do to one side to get rid of it, I have to do to the other side. That leaves me with 221 plus x, which is equal to 80 times 4 is 320. Now, I need to subtract 221 from each side. And this leaves me with x, which is now all by itself, and x is equal to 320 minus 221. Lachlan? Nope, it's not 90. 99, yes, x is 99. So what does she need to score on her final quiz? 99%. So that she can have an average of 80%. That is it for today's lesson. Your homework is the lesson 1.1f homework section. That is going to be your homework. Thanks for watching. We'll see you next time.